All right, let's just jump right in. I want you to picture something. You're staring at your production dashboard. Everything looks perfect. I mean, all your SLOs are green, the system is humming along, users are happy. But what if I told you that right now, with all those green lights blinking, your entire system is already completely owned? Yeah, look at that. Uptime is rock solid, latency is barely a blip. All your metrics are basically screaming that everything is perfect. And this right here is the moment that tricks so many dev teams into a false sense of security. Because, the app works. The login is smooth, the UI feels great, everything feels safe. And then, bam, this pops up. A critical alert. Someone has full admin control of your system. And you're probably thinking, how? Was it some super complex zero-day exploit? Nope. They literally just walked in the front door. Why? Because a critical secret, a key to the kingdom, was just sitting there, in plain sight, right in the JavaScript code running in the user's browser. And this quote, it just nails the problem. This isn't some tiny bug you can patch. No, this is a total, catastrophic failure of the architecture itself. The second a signing key like that gets out, the whole system of trust just evaporates. An attacker can now pretend to be anyone, sign any request they want, and yeah, that includes your admins. So the big question is, how does something like this even happen? Well, believe it or not, this kind of mistake is getting way more common. And a huge reason for that is how much we're all starting to lean on AI to write our code. So let's really dig into the systemic problem that led to this mess. Yeah, we're officially in the era of what some people are calling vibe coding, right? We just throw a natural language prompt at an AI, build me a login system, and boom, we get whole features generated for us. We're moving at an insane pace. We get to focus on the what, the cool logic, the slick user experience, and we let the AI figure out the how. The problem is, all that speed is hiding a brand new and really dangerous layer of security holes. There's this great metaphor from an Ox security report that I think is just perfect. They call these AI coding tools an army of juniors. And it makes so much sense. They're super eager, they're incredibly fast, and they pump out code that actually works. But they have zero architectural judgment. They don't have that gut feeling for security that only comes with real-world experience. And this table shows you exactly what that lack of judgment looks like in practice. Just look at that second row there. The AI's only goal is to make it work, right? So to just get it done, it might stick a secret key right into the front-end JavaScript bundle. Sure, it solves the problem in the moment, but it also means literally anyone on the planet can just right-click, view page source, and walk away with your keys. Sound familiar? That's exactly what happened in our opening disaster. So here's the absolute bottom line. An AI assistant is basically flying blind. It's just replicating patterns it saw in its training data, and it's always going to pick the simplest path to a working solution. A human architect, well, that's a completely different game. They're thinking about the entire system. They get the full context, and their job is to draw the lines in the sand, to define the security boundaries. Okay, so this whole context blindness thing, it has massive implications for us as engineers. It seriously feels like the ground is shifting under our feet. Our role isn't just about writing code anymore. It's evolving into something way more critical. And that's really what this channel is all about. Tackling these real-world production engineering lessons, not just surface-level tutorials. So if you're building stuff with AI, or you know someone who is, do them a favor and share this explainer. We need to get this conversation going. And of course, if you want to be part of a community that goes deep on production architecture and security, make sure you subscribe to Lalit Official. All right, so if that's the problem, what's the solution? How do we actually architect for trust in this new world? Let's talk about the right way to build these systems so that these catastrophic failures just can't happen. Everything, and I mean everything, starts with one core concept, the trust boundary. Think of it as a hard line drawn in your system. And the number one non-negotiable rule you have to remember is this: the browser is not your friend. It's an untrusted, hostile environment. Assume anything and everything on the client side can and will be looked at and messed with. Okay, so if we can't trust the browser, what do? We need a bodyguard, a secure proxy. And one of the best patterns for this is called the backend for frontend, or BFF. It's just a dedicated server whose only job is to handle requests for your frontend. And here's the magic trick. The BFF holds all the secrets. The frontend, it never even gets a peek at them. Ever. So let's walk through how this actually plays out. Step 1, Your user's browser makes a request, but it doesn't go to the main API. It goes to your BFF. Step 2, the BFF steps in. It checks the user session, grabs the secret key from a super secure place like a vault, and then it signs the request. And finally, step 3, the BFF sends that freshly signed, totally secure request onto the real backend. See what happened there? The secret key never, ever left the safety of your server. Think of your BFF, this trusted server, as the ultimate security guard at the gate of a fortress. It has a very strict set of rules. First, it checks your ID on every single request, no exceptions. Second, it assumes everyone trying to get in is hostile, so it frisks all incoming data for weapons, sanitizing it. Third, it uses special seals, cryptography, to make sure no messages have been tampered with in transit. And finally, it only holds the keys to the specific doors it needs to open, nothing more. That, my friends, is zero trust in action. So when you see this kind of architecture in practice, you start to realize it points to a much bigger idea about how our jobs as engineers are changing because of AI. It really isn't just about cranking out code anymore. I want you to just look at this number for a second. 45%. A recent study by Veracode found that nearly half, almost half, of all AI-generated code they tested failed basic security scans. This is not some abstract what-if risk. It's a real, measurable, and huge problem right now. And this quote just says it all, doesn't it? Our job isn't primarily to be the implementer anymore. We are now the architect and reviewer. Our most important function is to make sure the things we build aren't just working, but that they're structurally sound and fundamentally secure. And that's really the core lesson here. Treat AI like an incredibly smart and fast assistant. Use it to speed up your coding, but never, ever delegate the job of being the architect. The big decisions, defining trust boundaries, protecting secrets, that responsibility has to stay with a human engineer. Period. So, I'm going to leave you with a question to think about. When you look at how your team is using these tools right now, is your AI a valuable colleague, helping you build amazing things faster? Or is it a silent liability, quietly weaving architectural time bombs into your code base that you just haven't found yet? Okay, let's wrap this up. If we circle all the way back to that breach we saw at the beginning, the main lesson here becomes crystal clear. Remember, that hack worked not because the attacker was some kind of genius. It worked because of a rookie architectural mistake. The entire system was built on a faulty assumption that the browser could be trusted with a secret. The vulnerability wasn't in the code, it was in the blueprint. The architecture itself was the flaw. So here's what I want you to walk away with. First, AI is amazing at spitting out code that works, but it has zero architectural judgment. Second, that means it's on you, the human engineer, to define the trust boundaries and guard the secrets. So by all means, use AI to go faster, but always, always rely on human expertise to make it secure. Look, if this explainer sparks some ideas about AI and security, please share it with your team. We need to be having these conversations. Hitting the like button really helps other engineers find this content. And if you subscribe to Lalit Official, you won't miss the next time we go deep on real-world production architecture. Thanks so much for watching.